This is the final result of this video. A survival game that asks us whether we should go to Mars or whether we should go to the Valley. I think we should go to the Valley. Okay. Oh, and we get the same options again the second time. Okay, so let's do Valley or Mars. Let's go to Mars. Okay, we only have that much hunger and thirst left, so let's go to the forest. I'm excited to do this project with you and see because it goes over several of the fundamental concepts, like how do we do multiple files in C? How do we compile everything? How do we use structures? How do we use pointers? All of the source code is available in the description below. Start this off by creating a main.c file. Your entire program runs in this block of code here, this function. So when this function starts is when your program starts, and when this function ends is when your program ends. This function can call other functions or other blocks of code, and you can structure your whole program that way. This is what we refer to as the entry point of the program. Start this off by outputting the title of the game to the console. To test all this, go ahead and open up a terminal. Come in here and type gcc main.c, and we're going to output a file called survival. Now, on Mac and Linux, it's going to output just survival. It's not going to have anything after it. And on Windows, it'll be survival.exe. Let's come in here to run it, // and then the name of the program, survival. And there we go. And it outputs welcome to survival game. Now, we're going to be compiling our code a lot. So let's come in here and let's make a script for this. First, if you're on Mac and Linux, go ahead and create a new file called compile. Inside of compile, go ahead and just type the command that you typed in here. Now, by default on Mac and Linux, when you create a script like this, you need to give yourself permission to also run it too. You need to say, hey, this file is safe to run. So we'll come in here, we'll go to the terminal chmod +x, and then the name of the script, which is compile. No news is good news. If you don't see anything come back, then that means, okay, I did it. Come in here and delete the survival one. Okay, and then what we're gonna do is we're gonna run /compile and hit enter. And if everything worked, you should have a survival program come up. Let's come in here, we'll do /survival, and it should run the program. This compile script will get bigger later on, so it's super helpful to have a separate script. On Windows, go ahead and create a new file called compile.bat. We're going to type exactly the same command in here. Now, in Windows, you don't have to say that a script is safe to run or anything like that. So let's come in here. We're going to open up a terminal. Come in here and do the same thing, /compile.bat, and hit enter. And there we go. You should now have a survival.exe file. Now, when you run it, you can do /survival. The .exe part is optional, and then hit enter, and it will run your game. Let's jump back into main.c. To start off our game, let's start off by creating the player. Let's create two files, player.h and player.c. Let's dive into player.h. In player.h, we're going to create a structure. A structure tells the computer how to lay out the memory. So we essentially have, let's see here, we have 42 bytes. The first 30 is the name of the player, and then the next 12 for each are integers for what the current hunger, thirst, and health is that the player has. So imagine the computer is this block of code that's like 42 bytes, and essentially that's the player data there. In this same file too, we're going to declare functions that the player can do. So one of the functions, one of the blocks of code that we can do is setting up the player. It takes in a player and it takes in a pointer to a player. So a pointer basically says that there is a player here at this memory. If I were to do this, it would make a copy of this player and pass it to this function, pass it to this block of code. But we don't want to do that. We don't want to make a copy. So we're going to say, hey, there is a player here at this location. Do all of your code, do all of your logic on that player there at this point in memory. It sounds complicated, but I promise you that it's actually really powerful once you get the hang of it. Another function or block of code we're going to do is displaying the player. Again, taking in a pointer to a player. When we do these, we're declaring functions. So basically all we're saying is that there is a function called this that exists. But we need to actually do the code for it. We need to actually make the blocks of code by defining the functions. So let's come in here and we'll copy this and let's jump into player.c. Go ahead and let's paste here and we'll come into player.h. Let's bring the other guy over there. And there we go. What I like to do is I like to just come in here and get rid of these curly brackets, or get rid of the semicolon and add curly brackets. And I like to do the same thing here. So in the player.h is where you basically declare all of your functions, and the player.c is where you define all your functions, with some exceptions, but for the sake of this video, we're not going to get into that. So you might notice that if you hover over here, it doesn't know what the player is. It's like, what are we talking about? Where's the player? We need to tell it where the player is, like which file it's in. So let's come up here up to the top, and we're going to hashtag include player.h. The way that this works is a hashtag include actually copy pastes all the code into this file when it compiles. You might be thinking, well, why don't we just put everything in player.c? Well, it's because player.h is sort of the common ground. It's kind of what glues or connects everything together, these .h files, whereas the .c files are sort of the internal code, the internal workings of the file. You know, .h and .c files are actually quite powerful because you can have some parts of your code that are more sort of private to the rest of the program, and then the .h files are where a lot of the code is more common. The .h files are sort of like, this is all of the code and functions and structures that I'm revealing to the rest of the program, which we'll get into a second. Let's dive into player.c. Let's come in here and we'll ask for the player's name. Now we're doing printf, so we need to come in here, we need to include our standard IO. IO on the computer refers to input and output. So this has a bunch of code, a bunch of functions inside of it that let you input and output to files, input and output to a terminal, input and output to the internet, all sorts of different really useful functions that basically just input and output to things, just send data and receive data to things. So in this case, we are sending data to the console. We're like sending this string, this text, to the console. We're outputting it to the console. What we need to do is we need to get the player's name from the user. I think this is a great opportunity to create a really helpful function for this. Come up to the top and we're going to create a function called input. It's going to take in a destination, like where should I put the text that the user types. You're basically saying, I want you to put this text at this location in memory. The limit allows us to set a limit on how big the input is going to be. This is important because our player can only store up to 30 bytes of text of some sort. We don't want it to go over that. That's actually a security flaw called a buffer overflow. The fgets function is what actually asks the user for user input. When you're in a terminal and you're running your program, I'm not running the program right now, but let's say that the user types a bunch of stuff and then they hit enter. This fgets is what actually gets that input from the user. And then it puts it in this location in memory, wherever you tell it to put it. It reads up to a limit of characters, right? So let's say that this is really, really big. I would read up to, let's say that this is 30. I don't know if this is 30 or not, but it would read up to that many characters and then not read the rest of them. Now, standard in is the input from the terminal. So anytime that the user types stuff in the terminal and then they hit enter, that's standard in. That's basically, we would refer to it as a file, but you could think of it as like a stream of data, right? Somewhere that we're getting the data from. In this case, we're getting the data from the terminal when the user types something in and they hit enter. Now, one thing about fgets is that it also gets the new line character at the very end. So when you hit enter, it puts a little new line character. Let me show you real quick. In main.c, there's this little thing that we wrote earlier. This makes the terminal go to the next line. It's actually a character and you can't see it. It's one of the characters that's not printable, that doesn't actually display. We need to get rid of that. We don't know where it is, so we're going to start from the beginning of the string, and then we're just going to keep going all the way until we hit it. So we'll start at the first one, right? First one, second one, third one, fourth one. Each time that we're doing it, we're checking and seeing, is this a new line? Is this a new line? Is this a new line? If we actually end up finding it, we're going to replace it with a null byte, with a 0 byte. Have a look at this ASCII chart for a second. I'm going to link this in the description below. So when you type an A on the keyboard, a capital A, it's really the number 65. And when you type a lowercase a, it's really the number 97. Every single character that you type on the keyboard actually has a number associated with it. Even characters that you can't see, like the space is actually 32. What's interesting too as well is the numbers. See, when you type a 0 on the keyboard, it's actually the number 48. And when you type a 9 on the keyboard, it's actually the number 57. This may seem like it doesn't necessarily make sense, but it's actually very useful because it allows us to distinguish that this is a character 9 versus the actual number. In the beginning are actually a bunch of different characters. So everything on the left that you see are characters that cannot be printed to the screen. A couple of these characters, such as this one and this one, control whether you should go to the next line. So when you're typing on your computer and you hit enter, depending on the operating system that you're on, it may either add just a new line there, or it may add a carriage return or some kind of combination of those two. And there's actually several other characters, like the bell character on some computers like mine actually makes a sound. So this one up at the top is null, this is 0. Every single one of these characters you see on the screen takes up 1 byte or 8 bits. So if you set it to one of these, then all 8 of those ones and zeros, all 8 of those bits are going to be zeroed out. Which that is actually not something you can type normally on your keyboard, but we use this character to kind of say like, this is the end of some text in C, or this is the end of a string in C. We refer to this as a null terminated string. So we're going to terminate our string with the following. And when we do this, if we print it out later, printing out is going to basically do all the characters up to that null character there. Some of our functions we're going to call later are essentially going to know where to stop. If we found it, let's stop the computer. It doesn't need to keep going. Let's just say return. Let's now use our input function. So we'll come in here, we'll say input, and we're going to pass in the player's name. So that's the location that we want to put the text in. And then the limit. Now, the player, if you have a look at this here real quick, was 30, right? So we probably want to do 29. And that way, if we go up to the limit, right, it'll be -0. So we're going to put 29 here for the limit. This is kind of an arbitrary number in our code, and we can make a constant for this so that it's easier to edit later. Let's go up to player.h, go up to the top of your code, come up here and declare a constant. I want you to compare these two for a second. These are extremely similar to one another, but they're two ways of doing constants in C. This first one is like a copy paste. So whenever you type this in here, it's going to put this into the code when you compile it. It's not going to change this actual file, but it's going to change the data that it's using to compile it. This is an actual variable in memory. And so when you use this, and then you put, player name size here, it's going to reference that actual variable. So with this, you're saying, I want another 4 bytes to declare this constant. Let's use this one. So we're going to come in here, we're going to take player name size, and we're going to move it down to the name and paste right there. And that way, if we ever want to change this later, we can just come up to the top. Now let's go into player.c and find where we're doing the input. And we're going to do the same thing. We're going to come in here, do that, -1. We want to do 1 less. That way we're not going to overflow. Perfect. So now that we've got that, let's now set up the rest of the player. So we're going to set the health, hunger, and thirst to 100. And again, these are kind of arbitrary numbers in our code, right? It's going to be harder for us to find these later. So let's actually make constants for these as well. Let's go up to player.h and come up here and make constants for these two as well. Now, in doing this video, health and hunger, it's really easy to mix those two up. But yeah, we'll do constants for each one of these and it'll make it easier for you to edit later. Let's dive into player.c and go ahead and replace each one of these with the constant. So player hunger, see, I already mixed it up here. It's actually player health, player hunger, and player thirst. Kind of glad you saw that. I didn't even plan that. Now let's come down here to the display function. In this function, it's going to display the player's stats, so their name and then their current health, hunger, and thirst. The way we're going to accomplish this is that whenever you see a % something here, right, like %S or %D, which we're going to get into in a second, this is kind of like filling in the blanks. So it's going to take whatever the player's name is, like let's say that my name is Alex. It's going to come in here and say Alex's stats. So whatever is here is going to replace this %S. This is called a format specifier, and there's several of these depending on what type it is. So the S is a string. It's like a bunch of characters. So %S puts a string in here. Have a look at this one. So it $D, you could think of D as digit, so it's going to put some kind of a number in there. $D correlates to an integer. So player.health is the integer that's going to go inside of here. So let's say that the health is 85. It's going to say health:85. Let's also do the other ones too as well. So again, just make sure that health and hunger, make sure you don't mix those two up. After each one of these, we're going to do a new line just so that it goes to the next line. We have everything in place to test this. Now let's go ahead and we'll dive into main.c, and we're going to come in here and we're going to do #include, and we'll do player.h. Now there's actually a huge problem with this, and that is that we have a player.h here, and in player.c, we have another player.h here. Again, when you do #include, you're sort of saying, put this into the source code, like copy this into the program. The problem with that is now this is going to be copied twice into the program. It's going to be copied here, and it's going to be copied here. There's a way to solve this. Let's go into player.h. We'll go up to the way top, and before any code that you write, we're going to create header guards. So this basically says, if this has not already been defined, we're going player.h, this just arbitrary kind of thing that we're coming up with, we're going to define it. We're going to say, okay, player.h is now something. We're just declaring it in our preprocessor. Then the next time that this comes through and does a #include, it's going to already be defined, and so it's not going to include all of this code. Let's come down to the bottom here. Super important. We're going to come in here. We're going to do indiff. So basically, all of this code inside of here is all inside of a header guard. And this header guard is going to ensure that this code only gets included once in the source code. If you don't have these, it's going to say that player is already defined. It's going to say you already wrote this, right? Why are you trying to do this twice? Let's come in here to main.c, and let's go ahead, and now that we've done this, we can now use the player. Go ahead and set up your new player. Now what we're doing here is we're declaring a variable player. This tells the computer, hey, make some memory for the player, make 42 bytes so that we can store information about the player. Then we call this player init function. Now, when you do this little and sign, what you're saying is I'm passing sort of a reference to the player. I'm passing a pointer to the player. Instead of actually copying all of the memory here, we're saying, no, just reference the memory. Just when you do all of the code that you want inside of this function, just do it on this memory here. Do it on this variable here. Don't make a copy of it. We're going to similarly call the player display function. So again, we're just saying, hey, reference this memory when you do the display, right? Print everything out that this variable's got. Let's now come in here and let's compile this. Now we need to change our compile script around a little bit. Let's go ahead and we'll dive into into our compile script. On Linux and Mac, we're going to change this to the following. So we're going to first compile all of our .c files, and then we're going to glue everything together with the linker at the last stage. So the way this works is that it's going to take main.c and player.c, and it's going to turn all that into source code. And then it's going to take those two files and it's going to glue everything together with this linker here. The output is what we call .object files. Object files are sort of pieces of the program that are already compiled, but they just need to be glued together. They just all need to be put together. So we run these two stages to do that. On Windows, you'll come in here and you'll type the following. So we're going to do something really similar. It's just we're not going to do the and signs or the semicolons. Let's come in here and compile this. Go ahead and open up a terminal. You'll notice when you compile it, there's these .o files, so those are the object files, and then it glued it all together into survival.exe. Let's run that. / and then the name of the program. You don't need to put .exe. We'll hit enter. And there it goes. And then what we can do is we can type in our name. And there we go. And it prints out all the stats. Let's jump into our terminal and we'll do /compile. And there we go. And it creates these .o files here. These are the source code that needs to be glued together. And then it glued everything together into this survival program. Let's run it. Let's do /survival. And there we go. Enter player's name. Let's do Alex. And there we go. And it prints out the stats. By the way, I don't want to make Windows look bad. You might have noticed Windows is a little bit slower. That was running through a virtual machine. For our survival game, the player is going to go to different places. Every turn, they're going to be presented with two different places to go to. Based on which place that they go will determine whether their stats go up or down. So if they go to the desert, for example, their thirst is going to probably go down by a lot. Let's come in here and we'll create a new file called place.h. We're not going to actually end up having any functions or anything for places, so we only need a .h file. Start out by doing your header guards. I like to do my header guards and then leave a bunch of space here. All your code is going to go right inside of here, and it's going to stay in here. Don't write anything after the end of. So like I said, places are going to basically drain or increase a bunch of stats of the player. So we need a way to distinguish between different stats. Let's create an enum to do this. So we have an enum called stat kind, and it has 3 different values. Hunger is 1, thirst is 2, health is 3. The numbers don't matter that much, except for they just need to be different from one another. Now, don't write this code that I just wrote. We're going to get rid of it. But basically, enums are essentially identical to what you see on the screen. They're really just a bunch of constants for different things, but what they let us do is they let us assign a name to some kind of value and let us distinguish between two different things. They're really nice because they make your code a lot more readable, where you can say if the stat kind equals health, right? That's a lot more straightforward than if the stat kind is 1, right? It's like, what does 1 mean? So anyway, enums are just essentially you could think of them as just a bunch of constants with different values. I'm going to get rid of these. Next, we're going to need a structure that has a stat kind in it and then how much it goes up or down. So it's going to hold like hunger -5, thirst +3, etc., etc. This stat, for example, so there's like 4 bytes here that represent what statistic it actually is, and then there's another 4 bytes here that represent how much, by how much it is. Let's now actually define the place that the player can go to. Now, here's a different way of declaring strings. We can declare strings as pointers, and we can make the memory somewhere else and have this place point to it, as opposed to what we did with player, right? Don't turn here. I want to show you something here real quick. Notice how with player, we actually declared this. This is saying the player is being responsible for those 30 bytes here, right? On the player, the first 30 bytes of the player is the name. But in this case, here's another way that we can do it, where the place isn't necessarily responsible for that, and the place is pointing to somewhere else in memory where the name or the message is. This is useful for when you don't know how big those are going to be. And we'll kind of I'll show you how we use this a little bit later on and why this is useful. We're going to have up to 3 modifiers. We're going to have space for 3 modifiers of some sort. Then we're going to keep track of how many modifiers that we have. And that sounds a little bit confusing. So what we have here is we have memory for 3 modifiers. Each modifier is about 8 bytes. So that means we're saying, okay, we need 24 bytes, up to 24 bytes. So let's say that our modifier count is 2. So we're only going to be using these first 2. Now that seems like a waste, right? Oh, why don't we just do this? But it gives us the flexibility to be able to have as much memory as we want. If we were to heap allocate this, you might actually end up wasting more memory just because of how heap allocation actually works. It tends to actually leave a lot of blank spaces just like this. This is actually quite a lot more common than you might think. A lot of lists or vectors in other languages that you might be using actually may be using a lot more memory than you might actually think. They might ask for memory and have a bunch of empty spaces at the end of it. So coming back into our code, we're gonna basically have memory for up to 3 modifiers, and then we're gonna know how many modifiers that we have. So maybe we have 1 or 2 or 3. Perfect. And now that we've done this, let's go into main.c. And up at the top, we're going to include our place.h. Now how do we actually declare our places? Let's create a constant of how many places that we actually have. Now again, this is the different way of doing a constant. So this actually stays in memory. In C, this is how you do an array literal. You use, you might have seen, you don't actually have to specify a number of places if you have something after it. If you hover your mouse over it, currently, it will end up being this. It's an array of 0 places currently. So we'll come in here and we'll hit enter. In order to define each place, we're also going to use another set of curly brackets and we'll hit enter. And then you can type dot, and you might notice that all of the members of that struct show up really nicely. So let's come in here, we'll do name, and we'll say equals forest with double quotes. We cannot use single quotes in C for a string like this for multiple characters. Let's come in here and we'll do this. Dot message. Let's say you eat berries in the forest. Now let's say that I want to do this to the next line. Watch this. This is how you do a multi-line string in C. You come in here and you just type another set of quotes. You don't need to do any plus or anything like that. Just keep typing. And then are attacked by bees. Perfect. There we go. Let's do the next one. So we'll say modifiers equals. Now modifiers is an array, so we're going to use an array literal again, just curly brackets and hit enter. Modifiers is 3, but it's okay that we're saying this is what modifiers is. We're going to initialize the first 2. So we can come in here. For each modifier, we can just initialize it like so, and we can say dot kind equals hunger, and dot amount equals 10. And there we go. Now, this is a little verbose, so I want to show you a different way. Go into place.h, and if you take a look in modifier, stat kind is the first thing, and then amount is the second thing. So we can also write it like this. Check this out. We're going to come in here. I'm going to get rid of just where these curly brackets are. We'll put another set of curly brackets, and we'll say hunger, and we'll say 10. So you can also initialize it, right? Because the stat modifiers, or sorry, the stat kind is the first thing, and then the amount is the second thing. So you can also do that. Let's put a comma at the end and hit enter, and we'll say health, and we'll say -5. Whoa, what happened there? Okay, there we go. So yeah, we'll say health -5. Let's set our modifier count. So let's come over here to 15 and then do modifier count equals 2. Just make sure that you set each one of these fields. Now this is a good template for all the rest of your places. Let's go ahead and we're going to copy this and we'll do that, and we'll go from there. So let's do this one as well. So I'm going to change it from forest. I'm going to change it to desert. For the message, we're going to come in here and we're going to say, you find little water in the desert and are attacked by tumbleweeds. Let's also keep the modifier count as 2. And let's put the health to -5. We're going to put the health to -5, and then we'll put the thirst to -15. So now we have said that we want 5 places. I think 5 is a good number for your game. At least 5. You can do more than that, but we have 2 so far, so we need to add another 3. For the sake of the video, I'll just show you. So Valley is the third one that we did. It has a modifier count of 3. And take a look. So we have 3 modifiers inside of here. You can have up to 3. So don't do anything more than 3. The next place that we visit is Mars, and this has a modifier count, and it makes the thirst and hunger go really down. So on your trip to Mars, you'll become very thirsty. And then finally, we have a mountain here. So modifier count of 2, and then we have our 2 modifiers here. So now we have all of our places. Let's come over here and we'll scroll down to the main function. The game is going to work in turns. It's going to keep taking turns until the player runs out of either health, hunger, or thirst. First, we're going to keep track of what turn that we're on. So it's going to start out at 0 and just go up every single turn. Next, we're going to keep track of whether the game is currently playing or not. The game will continue to play as long as the player has health, hunger, and thirst, as in those 3 do not drop to 0 or below. In C, 1 is true and 0 is false. So if this ever gets set to 0, that means that it's false, and that means we'll not be playing the game again, anymore. We're going to put the entire game in a while loop. So the way this works is that it's going to keep running the code inside of these curly brackets here as long as this is true, as long as this is 1. While loops are useful for when you don't know how long it's supposed to run for, whereas a for loop is useful for when you know. So let's say that you have 30 students in some kind of an application. You know that the for loop is going to run through 0 all the way to 30, right? So let's say, for example, that you have an application that keeps track of students. A for loop is useful for looping through those 30 students because you know that there's 30 students inside of there. But let's say that in this case, we have no idea how many turns the player is going to go for. The game could run for 5 turns. It could run for 30 turns. We have no idea. And so because of that, this is where a while loop comes really useful. We're going to keep running the code until something is no longer true. Let's print out the current turn that the player is on by saying day and then whichever turn. Again, format specifier, the turn is going to be filled out here. Now, earlier we did a player display. I'm going to cut this. We're going to move this into our while loop. So let's do Control X or Command X if you're on a Mac, and we'll paste it right there. We need a way to get 2 different places. So we need a way to get random numbers. The way that a random number generator works on a computer, well, the most common way is through a pseudo-random number generator, which basically takes some number and then just keeps running an equation on it. So what you're looking at here is a Fibonacci sequence. It takes these 2 numbers, right? We're starting with the seed, which is 1. So it takes 1 and 1, adds them together. Then the Fibonacci takes these 2 numbers, adds those together, and gets this. Takes these 2 numbers, adds this. Takes these 2 numbers, and adds this. So a Fibonacci sequence is actually a very bad random number generator. But let's say that we wanted to take every single one of these and get the first digit out of those. So if we got the very right digit and just threw away everything else, we would kind of get an interesting sequence of numbers. Now, this is actually a really bad number generator because let's change the seed, for example, to 5. Now you'll notice that it only gets 0s and 5s. And if you change this to a even number, I believe it all inputs even numbers. Let's see. Yeah, so you wouldn't normally use a Fibonacci sequence for this, but there are other algorithms, such as the Mersenne twister algorithm, that can be used to achieve random numbers. Now, in addition to this, there are algorithms that are used for cryptography. We're not going to cover that in this section, but those are very, very strong equations that take a lot longer to compute. Whereas for this game, we're just going to use a very simple random number generator. There is, in fact, one built into C, into the standard library. It's not the most amazing random number generator, but for the sake of this game, it's okay. Let's come over here and we'll scroll up to the way top. We're going to add two different functions. The standard library, this is a bunch of helper functions for common things in programming in C. And then time.h, which will get the current time. We're going to use the current time as a seed. The seed being the starting number that you work with the random number generator, like we saw. Computers are actually capable of counting from seconds and milliseconds from a certain date. And this is how it actually keeps track of the current time. So on my computer, for example, there is a function called time in the C standard library, in this time.h that we had. And it says it returns the time as the number of seconds since the epoch, 1970, January 1st at midnight. UTC time. So basically my computer is counting, because I'm on Linux. If you're on Mac, it's also the same thing. My computer is counting the number of seconds that have happened since January 1st, 1970 at midnight. Now, just a fun fact, if you're on a 32-bit machine, you have actually until 2038 until this number will essentially overflow. A quick Google search, according to Google, Microsoft Windows, their epoch time starts from January 1st, 1601. It is actually possible that Windows might use the Unix POSIX when running through MINGW. That MINGW might sort of compensate for Windows's epoch, but that would be an interesting program if you want to try that out. Anyway, let's go ahead and we'll scroll down. Right before the main function, we're going to create a new function. This is going to get a random integer between 0 and then the maximum, whatever it is. Rand gives you a number between 0 and rand max. So on my machine, let's look at rand max. So rand max is defined as that number, which is the maximum value for a 32-bit integer. So anyway, random is going to give you a number between 0 and rand max. What we can do is we can use the modulo, which gives you the remainder function, in order to get that maximum. Have a look at this chart. So 1 modulo 5 equals 1. 2, 2, 3, 3, 4, 4. And then you have 0. So what's really cool about the modulo is you get this repeating pattern. So if I do, for example, 10 modulo 5, I get 0. So it's 1, 2, 3, 4, 0. 1, 2, 3, 4, 0. 1, 2, 3, 4, 0. It just keeps going and repeating. Check this out. If I change the mod to 2, for example, you get this repeating pattern, 1, 0, 1, 0, 1, 0. So it doesn't matter how big the number that it is. If you're doing modulo or the remainder function, you just get this nice repeating pattern. So basically we're saying that maximum is 2. So you'd get, 0, 1, 0, 1. So this would be your random number, whatever rand returns, which is some massive giant number. And then you just run modulo on it and you'll get either a 1 or a 0. Or let's say the maximum is 3, so it'd either be 0, 1, 2 or 0, 1, 2. Last thing with this random number generation, before the whole program starts, go to the very beginning of your main function. And then we're going to seed the random with the current time. So we're calling the time function, just the one that we looked up earlier, right? And we're getting the current time. Time t on my system is defined as a long. So it's defined as a 64-bit number. My computer is not going to overflow for a very long time, way past my lifetime. And then the srand, this actually seeds the random number. So it takes some kind of number in. It's kind of interesting because srand actually takes in an unsigned integer, but this is completely okay. It'll just overflow and it'll give us a value between 0 and the maximum, which is about 2 billion. And that's completely fine for this case. Let's go ahead. We're going to scroll down to the while function, not while function, while loop. Let's go ahead and pick a random place from our places array. We're going to pick another place from our places array, doing basically exactly the same code. We're going to make the turn go up, right? We've currently taken a turn. Now what we're going to do is we're going to get user input. We're going to ask the player, which one of these places do you want to go to? Now, it's possible that when you say, okay, type either 1 or 2 in, that the player types 50, or they type something completely wrong. So what we want to do is, while they are choosing valid input, we're just going to keep asking them over and over. So if they end up putting 50 in there, we're going to say, oh, invalid option, please try again. And then just ask them again. Let's come over here. We'll output the areas that we've chosen. We're going to ask the user to enter a number. And then we need to keep track of what they said. We need to remember what they said. So we need a variable for that. And then another way of doing it, another function you can use to get user input is with a scanf. So it takes in a format specifier. It's like, what do you want from the user? Well, we want a digit, a number of some sort. So we'll say, okay, %D. And then we're saying, put it into this memory here, right? We're doing the little and sign to get a reference and saying, when the user types that in, put it into this memory here, put it into this variable. Let's come in here and check whether it was 1 or 2. Now, there's obviously a third option. Maybe they chose 50, right? Maybe they chose something they shouldn't have. So if that's the case, we're going to tell them, please choose 1 or 2. This way, your code is exhaustive, meaning that it could handle all the different possible combinations of what choice is. Now, the code for both of these is going to be identical, so let's make one more function. So let's dive into player.h. We'll scroll down to the bottom, and we're going to come in here and we're going to create a function, a block of code for having the player visit a place. So we're declaring that this function exists. Now you might notice that place is, it doesn't know what it is. So let's come up here and we're going to do up at the top inside of our header guards, we're going to say #include, and we'll do place.h. We have header guards on this file as well, so it's completely safe for us to do this a second time in our code. Let's go ahead and we'll scroll down. Let's copy this function here. We've declared that it exists. Now we need to define it. Now we need to actually add the code. So let's come in here. We'll go to player.c. Go ahead and scroll down, and we're going to put it down at the bottom. If you're ever trying to think about what's the difference between declare versus defining, think of defining like looking it up in the dictionary, right? With defining a word, there's a definition, there's, all the examples, all that kind of stuff, right? It gets more specific about what that word is. Whereas declaring just means that the word exists, right? It doesn't have a definition with it. So in this case, if you're declaring a function, you're just saying that that function exists. Whereas if you're defining a function, you're actually putting the code in here. You're actually saying, this is what the code is for this function. First, let's output a message that's saying that you visit the forest or you visit the desert or whichever. This is going to be replaced with whatever the place's name is. Every single place also comes with some kind of message, like you were attacked by bees, or you were attacked by tumbleweeds in the desert or something. We're going to output that message to the console as well. Every single place may have multiple different modifiers, right? The desert, for example, lowers both the hunger and the thirst. So we need to loop through that. This is a case where we know how many times we're going to loop through it. So we're going to use 4. We know that we have 2 modifiers. So we're going to run this code 2 times, 1 for each modifier. Now we could just use a bunch of if hunger do this, else if health do this, else if thirst do this. We could do that. We could also use a switch statement. This is actually one of the reasons I really like doing this survival game in different languages, is because we can cover, a lot of the basic keywords when it comes down to flow, like for, while, switch. This project has pretty much a lot of them. First, we're going to write the code that checks whether the place modifier kind, like the is hunger. First, we're going to write the code that checks whether the place modifier kind is hunger. If this is the case, we're going to take the player's hunger and add it by the amount that it should go up or down. So if this is -5, it'll go down by -5. And if this is, if the modifier is 5, it'll go up by 5. Do exactly the same thing for thirst as well. Now, one thing is with these case statements, you also need a break there, basically saying break out of this switch statement. So this essentially, like, it runs, so if it was hunger, it runs this code and it says, okay, I'm done with this entire switch statement. I can move on to over here, is what it says when you do break. Last one that we're going to do is we're going to do the health. So yeah, just like with the other ones, if it's health, then we're going to add it or lower it. It's possible that you might add more of these later on. You might add temperature or energy or something to your game. So what we need to do is we need to handle if it's none of these on this list. So what we're going to do is we're going to add a default. So this says if it's none of those cases up at the top, then if it's something else, then we're going to run this code instead. We're going to say unsupported modifier. And here's what's really great about C is that you can actually put a line number just by doing this and the file number. These are macros. So for example, well, VS Code doesn't show me, but because this is on line 54, it's going to come in here and put 54 inside of here. This is a really useful macro for finding errors in your code later. And this outputs the file that you're in. So it will say player.c. Perfect. So we've done all this code for player visiting a place. Let's go ahead and jump into main.c again. And so we're in that while loop that we were previously, right? We're at the very bottom of the code. We're going to come in here and have the player visit a place. We're passing the player as a reference and also the place as a reference. We're not making a copy of either one. This is actually really important because the player is changing, right? We need to actually set those values on the player. If you did not have this, you would be making a copy of the player. It's erroring out because it expects a pointer to a player. But any which way, it would only change that copy of the player, and then that copy would be thrown away. But we want to say, no, we want you to change the memory here. We want you to change this memory here that represents the player. Same thing for the place. Now the place doesn't actually change, but either which way we can also pass it as a value too. Let's come in here and we'll do the same thing. We're going to come in here and do the same thing, except for we're visiting the place that's B, right? That variable B that represents the place. Perfect. Now, finally, what we need to do is we need to handle whether the player runs out of health, thirst, or hunger. We can just simply go and check those. Now, we're going to check and see if it is 0 or less than 0, because it's possible that you might be -5 or something. And if you don't do less than, then the player will still be alive, even at -5 health. And down at the very end, we're going to come in here and we're going to say you lasted a certain number of days. This is after the while loop for the entire game. To come in here and test this, let's go ahead and compile it. So both on Windows and Mac, you can just do /compile, and there we go. If anything comes back from this, then that means that you have an error. So no news is good news. In this case, there were no errors, so everything was good to go. Let's do /survival. I'm going to come in here. I'm going to type Alex. And we'll come in here. Oh, okay. Please choose an area. We're going to go to Mars. That was a really bad choice. Please choose an area. Let's go to the desert. Go to Mars again. Let's go to Mars again. Let's go to the desert. Let's do forest. We'll go to Mars again. Okay, so I lasted 7 days and I ran out of water. Now, a couple things about this. We used a script to compile all of our code. You might be thinking, well, why don't we just use make or cmake or something like that? I want you to see this command and for what it's doing, because all of those kind of fancy tools like make and cmake, which I would normally use too, this is ultimately what they're actually doing. So understanding this can help you understand make and cmake and what Xcode is doing and what Visual Studio is doing, etc. Like Visual Studio has its own compiler. I don't think it necessarily uses GCC. Either which way, if you made it this far, really good job. If you ran into anything, please leave a comment below. And if you have any suggestions for future projects that we can do in C, also feel free to leave a comment below. I hope that this has been helpful for you. Thank you so much, and I hope you have a good rest of your day.